In the previous video, we learned how to use unittest.mock to control the environment that our test code runs in so that the tests can remain focused on making sure one thing works properly. In this video, we'll take a look at the unittest package's ability to run many tests at once with a single command. We've seen how to easily run all the tests in a particular file, but for a large project, putting all the tests into a single file would be troublesome. They need to be separated into different files according to logical groupings, or the test suite will become unmanageable. On the other hand, it would be a pain to have to manually tell unittest to run the test in a whole bunch of files. If we had to test, list out each file. Fortunately, there's a way to have our test suite split up into many files and still run it with a simple command. We use a unit testing tool that supports test discovery, which basically just means it looks at the available files and decides for itself which ones seem like test files, then loads the tests from those files and runs them. The unittest package has a basic but useful test discovery tool built in. When we run python-m unittest discover, it searches the current directory for Python s, whose names start with the word test. In addition, it recursively performs the same scan on any subdirectories that contain an init.py file. Once it's collected the names of all the matching modules, it runs the test just as if we'd specified the modules on the command line ourselves. There are a few command line options we can use to adjust the behavior of unittest discovery. The first, which we saw in passing a moment ago, is the -v switch, which makes the test report somewhat more verbose. We used it here so we could see that the discovery had worked properly. We can also use the -p command line option to change the pattern that is used to recognize test files. Here, we've changed it so that file names ending in the word 1.py are recognized as test files. The unittest discover code also recognizes s-s to specify the directory where test search should start. Notice that by making suite act as the starting directory for the search, we've stopped it from being recognized as a package containing the test. If that's a problem, we could supplement the -s option with -t, which tells unittest where to find the top-level directory for this run. By using both -s and -t, we're able to narrow the test search to a particular subdirectory while still running the test in the context of a parent directory. There's a bit of a pitfall to be aware of when using unittest discovery code or any other test discovery that works by importing modules to check whether they contain tests. That pitfall is that the modules are imported. Most of the time, that's not a problem, but if the test discovery code imports a module that was meant to be a program entry point that might result in actually running the program, which is not the desired behavior. It's easy to avoid this problem when we're writing an entry point by wrapping entry point code in if name equals main statement. But if we, or somebody else, left off that check and unittest thinks the file looks like a test file, running unittest discovery code will have surprising results. That's about all there is. Unittest's test discovery tool. It doesn't have many features, but it does have the features that everybody needs. And there's a good chance that it's all we'll need for the majority of projects. For cases where we need more from our test discovery tool, we can use nose, which we'll look at in the next video.